Okay, you do not have this problem on your paper, but this is a slightly harder version of what you're getting on your take-home quiz. On your take-home quiz, you are asked, what is the limiting reactant? You are asked, what is the theoretical yield? What is the percent yield? And how much of the excess reactant is left? So you are going to be doing those things. However, on your quiz, you are given the balanced equation. Here, you have not. So let's together get the balanced equation, and then I want you guys to take a few minutes to see how far you can get on solving for the limiting reactant, the theoretical yield, and the percent yield. But you need a balanced equation. So it says 0.10 grams of barium sulfate is formed. So there's two things you can tell me from that. That number represents what? What? Thank you. Whatever it says, not whatever I said. What's typed. Okay, so that number represents what? The mass of what? Barium sulfate, which is a product. So that 0.7 grams is your, we just did it 30 seconds ago, say it, actual yield. So that is your actual yield. So you already have that part for your percent yield. But it's a product, so it's going to go to the right of the arrow. What is the formula for barium sulfate? BaSO4. Okay? So from the reaction of sodium sulfate. So sodium sulfate is a reactant or product. Reactant, what is the formula for sodium sulfate? Na2SO4. Okay, and you're given 1 gram of it to start with. Okay, and now what's the other reactant? Barium hydroxide. What's the formula for barium hydroxide? No, BaOH2, because it's this. And you're also given 1 gram of that. So what is the second product? Because what type of reaction is this? Double replacement. So what's the second product? Sodium hydroxide, and its formula is NaOH. Balance this equation. What do you need to balance this equation? You need a 2 in front of sodium hydroxide. Now this right here, this is the product you care about. So the sodium hydroxide, you don't care about, but you needed it to make sure what all the other coefficients were. Okay, so you have your balanced equation. This is how it'll be given on your quiz. You know your actual yield. You know the two amounts to start of your reactants to start your limiting reactant calculation. So work on this for about 10 minutes and then I will complete it for you. So we're going to take 1 gram of sodium sulfate, and we're also going to take 1 gram of barium hydroxide. And what we're going to do is we're going to find the theoretical yield just in moles of our barium sulfate. The reason I'm going to find it just in moles first is that way I only have to convert the one that I'm using to grams. If you took them both to grams, that would be fine. You've just done one small extra calculation. No big deal. Okay? So I need the molar mass of this, 142 point, someone's gotten it, right? 55? 0.05 grams of sodium sulfate, 1 mole of sodium sulfate, and then 1 mole of sodium sulfate, 1 mole of barium sulfate, because everything was a 1-to-1 ratio with the coefficients. Okay? So what do we get for that number? 0.00, give me 3 more digits.
703.
703. Okay, so if sodium sulfate is the limiting reactant, that's our product. But now we have to do this one. So what's the molar mass of barium hydroxide, please? 171.35. And so that would be 1 mole of barium hydroxide. And then again, we have a nice 1-to-1 mole ratio. And we get for this one 0.00584. 5 what? 0.584? Okay, so which one is our limiting reactant? Barium hydroxide is our limiting reactant because it made less product. That makes our sodium sulfate our excess reactant. So to find our theoretical yield in grams, we just take our theoretical yield in moles and convert it to grams. So what is the molar mass of barium sulfate? What's the molar mass of barium sulfate? You didn't have it on your paper?
233.4.
There you go. Okay, so we get 1.3 something.
I got 1.5.
1.5, okay. 1.5 grams of barium sulfate. And that is our theoretical yield. So to find our percent yield, it's the 0.70 grams divided by 1.5 grams times 100, which is going to come in really close to 50%. What does it come out to be? 46.3, which 46, because we only have 2 significant digits. Okay, so there's our percent yield. So the only thing left we need is our excess leftover. So we have 0.00703 moles of sodium sulfate to begin with. I know that because of this 1-to-1 ratio there, that it would be the same moles of sodium sulfate and the same moles of that. So we need to figure out how much we used. Well, if our 0.00, too many zeros, if our 0.00584 moles of barium hydroxide is our limiting reactant, well, we know that it's the same moles of barium sulfate and barium hydroxide because of the 1-to-1 mole ratio. And it's a 1-to-1 mole ratio of these as well, then we know that it is 0.00584 moles of sodium sulfate that we actually need to use. And so we can subtract to get the reactant left over. And then watch the quiz carefully to see if it asks for this in grams or moles. And if it asks for it in grams, convert from moles to grams. So we're going to have 9, 1, 1, 0, 0. That is assuming I did my subtraction right since I didn't use calculator. The limiting reactant is the barium hydroxide because it was the one that used less product. And you had more than enough. And since barium hydroxide and sodium sulfate, you know that it's a 1-to-1 mole ratio from the balanced equation. You have 0.05 moles of the barium hydroxide. You have 0.07 of the sodium one. So that's not a 1-to-1 ratio. Okay, so let me get you